Hello everyone and welcome to this latest video discussion as part of the RICS Tech Partner Programme. My name is Andrew Knight and I work within the knowledge and practice area of RICS, looking at the effect of data and technology right across the built and natural environment, right across the property life cycle as it affects our 110,000 members worldwide. And I'm joined with my colleague today, Aaliyah. Can you introduce yourself as well?
Hi, my name's Aaliyah Pollock. I'm a fairly new member to the team and I work alongside Andrew Knight looking at the impacts of data and tech on the built environment, as well as managing the Tech Partner Programme. My background is within geospatial science and I've got experience doing GIS in a wide range of environments, including the military and working for a major construction firm. I've now moved across into the data and tech analytics and I'm here today to interview Lewis.
Thanks, Aaliyah. And as she said, we're here looking at the overall effect of data and technology right across the built environment. And I'm really glad to have Lewis Kidd joining us today from Sims Parker and Kidd. So please do join us on the call, Lewis.
Hello, Andrew. Hello, Aaliyah.
Great to have you on the call. And before we get into the bits and bytes, it's always great to have a little bit of a backstory about yourself and the organisation. So really do give us a bit of a backstory, if you would, and an origin of setting up your organisation.
Okay, yeah, I was a very keen hobbyist drone flyer, and unfortunately I was made redundant. So I needed to work, I couldn't just retire. So I focused on providing drone services to builders and to the wider audience. And it's really taken off, and it's been quite good for us, and it's opened up new avenues for us to work with.
And tell me a bit, if you would, about the different kind of drones you've got, because I believe you've got a number of different drones that, depending on sort of weight and a number of rotors, and indeed fixed versus rotor. So take us a bit of a tour through the kind of equipment you've got.
Okay, so we've got what I believe to be quite a modern fleet. And that's split really three ways. As you mentioned, we've got fixed wing craft. So that's the Parrot Disco, which is essentially polystyrene with a plastic fuselage and a camera in the nose. And the reason why that's on the fleet is the lifetime that it has, or flight time, I should say, in the air. It's close to an hour. So from single charge, we're getting close to an hour, somewhere in the region of 50 minutes, depending on the wind condition. So we tend to use that more on the agricultural side of things. And then we divide the drones with props, multiple props, into two separate areas. We have the 4 rotor craft, which is predominantly DJI. Craft, and we go from the Inspire, which is perhaps the biggest craft that we have, and then we go into the Phantom 4s, the Phantom 3s, the Mavics, DJI Mini 2, DJI Mini 3, and then we have the Unique, and the Unique is the 6-bladed craft, and that is split between normal RGB camera and thermal imaging as well. And the reason for having the 6-bladed craft is it extends our operating window in conditions where it's quite windy, where the DJI craft, because it's 4-bladed, doesn't perform that well. The 6-bladed craft opens up that operating window for us.
And what sort of limitations are there, Lewis? Because obviously you've touched there on issues around weather conditions and indeed flight time, but also I'm thinking about things like payload capacity and perhaps the limitations that might bring in terms of quality of camera, or indeed, I guess, stability depending on the weather conditions as well.
Yeah, indeed, the main thing for us, they are quite stable craft in terms of interchangeable payload. We've got the Inspire 1, which we can change the payload on, and the Uniques, which we can change the payloads on. The others are fixed payloads. You'd only really change those in terms of a malfunction or damage to those. But in terms of wind conditions, we are limited but more importantly, it's the atmosphere, it's the precipitations, it's the water within the air, and the amount of water that's in the air that stops us from flying. So something like the Parrot Disco would be less affected by things like water ingress, because the propeller only has a single propeller at the end. It's a delta wing effectively, so that would be less prone to things like water ingress, but we still have to pay attention to that, and that could show up on the video that we're obtaining as well. So weather conditions in terms of rain, light rain, drizzle, and that sort of rain that just hangs in the air will mean, sadly, that we cannot fly under those conditions.
And what about from a licensing perspective, Lewis? What are the kind of requirements you need in terms of licensing, either generally across your drone fleet or for some specific models?
Okay, so we started out, the licensing has changed. It changed at the end of 2021. So up to that point, we operated, all commercial drone operators also operated under what was known as Permission for Commercial Operations. The slang is PIFCO, that we operated on. So you needed to be a commercial operator, and that required that you had to go on to a course to be able to read air navigation charts, understand those sorts of things. So up to 20 kilograms, that's what we're licensed for. That has changed. You can no longer operate under a PIFCO if you've not had one before. You can maintain that. What they've gone over to now is two other forms. What replaces the PIFCO is the GVC, or General Visual Line of Sight certificate. And that is subdivided down into the A2 CFC. So you need a combination of the A2 and the GVC to operate the modern drones which are coming along. So there's a little bit of an irony here. They're classed as C-class drones, C1, C0, C1, C2, C3. But we've not had those labelings applied to us yet. It's not happened. So we operate under the legacy programs. And what you've got is flying far away from people, flying near to people, and flying close to people. In essence, and cutting to the chase, it pushes you towards the drones, which are 249 grams. The other side of a toy drone in slow speed operation, to get the maximum to operate close to people, which is cut down from 50 meters down to 5 meters of uninvolved people, so people that you're not working with.
Yeah, thanks for that. You touched on the regulatory requirements there a little bit, but would you be able to explain this more generically and explain how the regulatory requirements vary depending on the different type of licenses?
Okay, so what everybody operates under is a broad umbrella of 150 meters. You have to be 150 meters away from people unless you have specific licenses. So a hobbyist can fly, they can fly their drones recreationally. You will have to register under the DMARIS scheme. So you will have to take the online test to get your flyer ID, and then you can fly, but you have to observe, you have to stay 50 meters away from uninvolved people and 150 meters away from residential, industrial and commercial places. Once you take the GVC, that then entitles you to get a little bit closer and operate to 30 meters of uninvolved people. If you have the GVC and the A2 CFC and you have a drone which is no more than 250 grams i.e. the 249 grams, then you can operate up to 5 meters of uninvolved people.
Okay, in terms of the drones, you mentioned that you've got RGB and thermal cameras. Overall, what cameras and sensors do you have?
Okay, so we only have 2. RGB, which is as we see the world in red, green and blue, and the thermal drones, which will give us a thermal density as to whether something is hot, cold, or somewhere in between, depending on the colors that are shown. So for example, something which is hot would show as either being a red, an orange or a yellow, and something which is cool or cold would be a blue or a turquoise greeny blue.
Okay, and using an RGB or thermal camera, what type of products can you create?
Okay, so we essentially get a heat map with using a thermal image. So if I can give you an example, something like a roof inspection. Not all roof inspections are the same. If we've got something like a flat roof, whilst you get a good picture of the roof, it wouldn't give you an indication as to what was going on in terms of water ingress, especially on a hot day. So this is where a thermal camera comes into its own, and it could give you the picture of the coolness, indicating that there was water there cooling an area or areas of the roof. In terms of other outputs, you could get digital surface models produced. Photogrammetry is perhaps one of the most popular that is out there, and that is something that we do too. But there are other applications, there are other models that can be generated.
Thanks, Lewis. I mean, that's fascinating. And I guess what would be interesting actually is if you could give us some examples of some kind of projects you've worked on, what the kind of the process is, what kind of software you might have used, and what kind of capabilities you've used, because it's great to sort of bring this alive when we think about particular assignments you've done. So perhaps you could talk about some of the things you've done and give us that kind of background on how it actually all worked.
Okay, so I work not exclusively, but a lot of work tends to be in building or building related areas. Roof inspections, developments of buildings, whether that be a house or whether that be a warehouse that's being developed. So it's a progression report, essentially, is what we tend to produce. We also get asked to scan areas of where a potential new development may be going in, piece of land for sale. Those sorts of things, and some of that output goes into a GIS, of which, Aaliyah, you said you're familiar with. So you could put in there the weekly progress and have those layered one on top of the other to see what was done in week 2 compared with week 3, week 4, and so on and so forth.
I mean, an example I was thinking of is whether you're doing things like digital surface models as well that actually give us that kind of 3-dimensional view. Is that something you've done as well?
It's not something that I have been involved with at this stage, but that's something I would be looking forward to getting involved with.
Indeed, and you talk about, obviously a lot of the things you work with are literally buildings, roof inspections. I mean, is it a mixture of kind of commercial and residential? You talked about logistics. Is it a real mix in terms of the building types that you're able to use this sort of technology and approach on?
It tends to be more on the commercial side of things. We do have residential clients, but they tend to be few and far between. It does tend to be more on the commercial side of things, working with builders and also working with a couple of local architects as well.
And is there a kind of also a different dynamic in terms of working perhaps in more urban areas or more kind of residential, not so much residential, but rural and out of town? Does that change the dynamic in terms of what you're able to do, or indeed the kind of projects that you look at?
It does. We tend to use different craft as we go away from built up areas, because we're quite restricted on what we can use. So we're getting to more towards your Phantom 3s of this world, Phantom 3s, the Parrot Disco, and the Inspire. So we tends to be agricultural, some in the forestry side of things, and the commercial sector in terms of industrial buildings as well.
I mean, it's interesting you mention agriculture there, because many people see our profession as being purely involved with the built environment, but many of our members are working in land and land use. And can you tell us perhaps some about the things that you've done more on that kind of agricultural and forestry side, and once again how the drones are being employed?
Okay, so I've had a couple of customers on the agricultural side of things, and what they're looking at is crop health. And you can see that again using the thermal camera in terms of healthy crops and ones that require spraying.
Indeed, indeed. Aaliyah, I know you wanted to probe a bit more about geospatial side of things.
Yeah, so you mentioned about using photogrammetry, so I assumed you've got capabilities to do 3D analysis, but are there any other types of geospatial capabilities that we haven't mentioned, such as imagery analysis or spatial analysis?
That's not an area we delve into. What we tend to do is to get the data, because there's a lot of data in terms of a picture. Picture's only one side of what's captured, and the clients tend to harvest the data within the pictures using their own GIS systems.
Okay then. So in terms of the data collected by yourselves, do you ever purchase any external data, such as LiDAR from DEFRA or any other types of satellite imagery, to potentially compare images over a period of time or land areas?
No, we don't buy in data at this stage, and it's not something that we'd be looking to do in the immediate future.
I guess, Lewis, I mean, it's an obvious kind of closing question, given that all that information you've given us and that kind of context of drones is really how you think the use of drones is going to evolve over the next sort of 5-10 years, because there's clearly an awful lot of use already. But what do you see the future looking like, particularly across all these different applications, not only the built environment, but agriculture, forestry, construction more generally?
Well, I think we've not really started to see the impact of drones and what they can offer. What we are seeing is the advancements. Really, I've seen significant advancements from when I started to now. They will become far more technical. I believe that the flight times will become longer, and they will be able to gather and process a lot more data. It doesn't mean to say that certain roles will become redundant. It just means there'll be far more information processed and ready for people to use to make better use of their time.
And do you think, from a kind of regulatory licensing perspective, that there'll be will it be easier in the sense, will there perhaps less restrictions? How do you see that trajectory moving? And also, I guess, in terms of flying outside of visual control, that sort of thing as well.
I think again, we're at the early stages. This is now what I've seen since I've been in the industry. This is the first real change when we've gone from the PIFCO over to the GVC. So I believe those changes will carry on going. I do believe that beyond the visual line of sight, that is set to grow. At this stage, it was only a few exploratory flights which have taken place. and people like Royal Mail getting involved and dipping their toes in the water. So along with those, you're going to get people like DHL and Whistle getting involved, because they're not going to want to be left out. In terms of regulation, I think that will become far more stricter into the future. Going into the future, I think we'll see more and more drones as they become even more popular. But along with that, we have to embrace that there will be far tighter technology, far more tighter regulations on that technology. You are talking about something which has a camera on, and for every good use of the drone, there is a potential for that to be used in a more negative way, and we have to accept that there has to be far tighter regulations. It can't be as it is at the moment, where if we look at the second-hand market, you can purchase a drone from eBay, and there's nothing there to force you to register. There's nothing to force you to register if you go and buy a brand new drone. So it has to be a little bit tighter, really akin with the gun laws, where if you're making a purchase, that you meet those requirements, you show your license, you've gone off, you've been trained beforehand, and you're acquiring a drone for which you can fly. So I think we're set to have far more regulations going into the future as the popularity of drones grow.
And Lewis, from a kind of technology point of view, do you see, in terms of increased battery power, for example, and thus the overall performance, and do you see additional payload types becoming even more used within the sort of technology perspective of what drones can do?
Yeah, yes, I do, for sure, Andrew. That is set to grow. Again, give you an example. When I first started to fly, you get your drone, you charge your battery, and off you go. Same product today. Once it is given network access, it checks itself automatically to see it has the most up-to-date software, firmware on that. It manages that itself. It will then update the drone, so it goes from the handset to the drone, and it tells you when it's ready to fly. Now, add in there for a little bit of spice things like AI as well. So using the data with AI on a drone, and for some people, I guess that's too much of Big Brother, if you like. That it could be used in those terms. So for you guys, local council, building inspections, they could have that data loaded up, and they could monitor a building, and let whoever the developer was to know whether they're inside the regulations or starting to step outside of the regulations. So these are sorts of things that in the next few years it would be feasible to have, I believe.
Indeed. Well, it sounds like it has a fascinating future for the foreseeable future, both in terms of perhaps tightening around the licensing side of things, but also the capabilities increasing as well. But for today, Lewis, it's been great to chat. Thanks ever so much for your time, and look forward to catching up again in the future.
Thank you. Thank you very much for the invite. Thank you.
Thank you, Lewis.
Thank you, Aaliyah.